At the beginning of this lab, the night before, you definitely want to put your potassium hydrogen phthalate, primary standard, in the oven. Put it in for an hour, and then take it out. Phthalate in the desiccator overnight, and make sure that you prepare your base first, and then use that to titrate your acid. Make sure you boil a liter of water. It doesn't have to be the night before, but you probably should because it makes your life a whole lot easier. The night before, you also want to prepare your 50-weight sodium hydroxide. The night before, you also want to prepare your 50-weight sodium hydroxide. If you don't, make sure that when you are done preparing it, that it is covered and then there is no air that can get in. It does this. A sodium carbonate precipitate. So make sure that after you've prepared it, that it's covered. You also want to make sure that you prepare a liter of this for the class, and here's the math for that. A 0.1 molar solution of our sodium hydroxide using our 58% sodium hydroxide that we just created. Now, this is a very concentrated sodium hydroxide, so you want to make sure that you don't get it on your skin.
We're going to drop enough potassium hydrogen phthalate to react with about 25 milliliters of 0.1 molar sodium hydroxide. Here is the math for how to do that. It comes out to be about 0.511 grams of potassium hydrogen phthalate. Use analytical balances to be more exact and more precise. Don't forget to, once you put your weighing book or whatever you are using to weigh your potassium hydrogen phthalate, in the balance to euro it or tare it to get it to the point where it just recommends resistance, and then you measure out about 0.511 grams. All of the potassium hydrogen phthalate that you had in the desiccator, desiccator overnight.
25 milliliters of DI water. 5 milliliters of water to your potassium hydrogen phthalate. So you need to swirl it until it does dissolve.
Add to our standardization versus the indicator that is outlined in the lab because it's easier. You're going to use microlab, calculate your endpoint, and figure out your molarity from there. When you set up microlab, you're going to add your pH sensor. You're just going to go into add sensor, choose sensor, pH, which is bad, accidentally millivolts, pH, click there. You want to actually measure pH, we're not measuring dissolved oxygen. You can either perform a new calibration or recalibration from file. We read the calibration from file because it was already there. You can ask your instructor how to perform a new calibration if it is needed. And you add that. The next thing you're going to add is your drop counter. You're going to go to add sensor, choose sensor, click the counter, go over to the one spot that is highlighted for counter, and click finish. We already actually have this set up, so it's already there. You're going to want to put on the graph section of the microlab pH on the y-axis and the drop counter on the x-axis. Next, what you're going to want to do, we already have it set up, is you're going to take your about 25 milliliter solution of potassium hydrogen phthalate and put it in a beaker on a stir plate, set up with the drop counter here, and you're going to put about your 0.1 molar solution of sodium hydroxide in the drop counter, and then you're going to perform a titration. Actually perform the titration, you're going to come into microlab and press start. First, you want to press start before you actually run the experiment. Then you're going to come over to your setup and turn on the dropper and the stir bar. Here we have a sped up version of the actual titration curve as the titration is happening. It takes long, so we sped it up. Sorry for the shakiness of the video. Once you begin to see it take a sudden spike upwards and then it curves back out and begins to flatten down, that's when you've actually reached your endpoint and you can stop collecting. As we see here, it's beginning to do so, and now you can stop collecting. The pH probe, you are going to want to squirt it off with DI water to clean it off. That way you're not introducing other chemicals to your solution each time you run the test. Prepare your 0.1 molar hydrochloric acid solution. You're going to do this using the concentrated hydrochloric acid solution from the stockroom. This is generally about 37 weight percent or 12 molar. Here's the math for how much of that you will need to prepare your approximately 0.1 molar solution. Standardize 0.1 molar sodium hydroxide solution to standardize your 0.1 molar hydrochloric acid solution. You're going to do this using a microlab titration the same way that you did to standardize your 0.1 molar sodium hydroxide solution. But for the titration, you're going to put your 0.1 molar sodium hydroxide solution in the dropper, and you're going to have your acid in the beaker at the bottom. Look for the endpoint and calculate the molarity based on that. Graph, which is what you're going to use to actually calculate the concentration of both your acid and your base. You're going to use Excel and to plot the first and second derivative of your graphs. You're going to come over and you're going to plot from the second counterpoint onwards for the first derivative, and then you are going to plot from the second pH minus the first pH on down. Then you can graph that with just a simple scatter plot. Go up to the insert charts. And it's the point, that's a random point, and it is the point where it goes up highest right there, that point. At 577 apparently for us. That is for the first derivative. For the second derivative, you are going to do the same thing, plot from the, except we are going to plot from the third counterpoint on down, and do what you did for your regular titration curve to your first derivative. We're going to do the second point of pH minus the first point of pH, and the first square, actually, and plot it down, plot a graph of that. This is just as a check, and where can't actually see it on this graph. But, okay, so stop right there. Our titration curve. This is the plot of our first derivative, with this peak being the endpoint. This is the plot of our second derivative, where we should go up and down like that. What you're going to want to do to this one is double click on the scale and go and change it from a fixed, or from an automatic 0 minimum to a minimum of what you look and see what you think would be a good minimum. I'm going to go to 500. And then it allows you to more easily see where it actually does. Once you've made it easier to see, you look for this spot on the graph where it crosses the x-axis, and that is where you look on the second derivative. Here's the math for how you use the number of drops of your base to solve for the molarity of your base. Here's the math for how you use the titration of your standardized base with your acid to figure out the molarity of your acid.